mining technique for each algorithm. Probably many of the researchers, including professor and their students, spend 2, 3, sometimes 4, 5 years, okay, to make the algorithm and test it and evaluate. So it does make sense to understand the specific algorithm within the several minutes, or 10 minutes, or 20 minutes. So it's not possible. Usually I'd like to give you the idea or what is the purpose of this algorithm and roughly explain about the pseudocode, usually the pseudocode or rough idea of the algorithm. So if you are interested in the specific algorithm for your the current research or any homework, then at the time you need to take a look at first textbook, not the PPT file. Okay, PPT file is just to show the overview of the idea, just the idea, or even though it doesn't include the pseudocode of the algorithm. The textbook has some details about it. So definitely you need to read the textbook. Then still textbook is not enough. That is the reason this textbook provides you huge. That's the one of the reasons I selected this textbook. It provides most of the important reference. Okay, you can find the reference by copying and pasting the title and the author, then the Googling, then you can find the most of the paper. Okay, then paper provide all the details. Even sometimes the reading one article or the paper is not enough. You need to find their reference also to utilize. Then finally you can understand the specific algorithm. That makes sense to understand the algorithm that has been developed by the many people and for a long time. Okay, so please do not. I don't think that you guys can understand right away. No, I don't think so. Even sometimes I don't know some of the algorithms. I know the title and the objective. I do not know the details of the algorithm or some code. Okay. Instead, I try to give how we can use such an algorithm or the clustering algorithm, classification algorithm. What is the objective? What is the difference? Then how you can study where you can use something like that. Okay. So these are not the general step of the developing the clustering task, but it's usually used in the research or the implementation of the application. So first one is a feature selection. Definitely, that is the most important part when you are doing the data analysis. It's not only for the clustering. It's not only for the specific algorithm. It's for in general. For any task of the data analytics, the first step is whether you guys can understand the data, whether you guys can characterize. Characterize means, what is a characterization? I'd like to characterize him. He's the handsome guy, he has the short hair. I'd like to characterize him. Then, if I can describe correctly, when I mention about him to others, they can understand who is he. If I characterize him as just a man, if I ask to find the Ibrahim, so can you find him using just a man? Not possible. So characterization, that means the feature selection that can describe correctly of your data. For example, this one, how to characterize this point? Using X and Y coordinate. The difference between this one and this one is not the shape of the circle that I draw, it's a position. So that is the reason we can use the X coordinate, Y coordinate. That is the best way to describe this data. I'd like to describe so I find the patient information in the hospital. How can we characterize this patient? So if I have the specific, the task for like the cancer, like the lung cancer, so I'd like to have some information about this patient, like whether smoke or not, smoking, because it's lung cancer. And we don't have to collect the information about how long the patient hair is. I'm not sure whether that is related or not. So it's just additional information. It doesn't affect it has a lung cancer or not, yes or no. We try to find the attribute that describes the best of your data. Then we can represent such a characterization with a feature. Sometimes it's called the attribute. Most of the time we use vector. So that is called the feature vector. Because x and y coordinate is simple. So two-dimensional data is enough to describe the position of this data. But the patient information, we have a lot of the additional information. So they can be represented by the feature vector. So that is the feature selection. Okay. So it depends on the purpose of the test or the test of interest. So that is the first thing, and also that is the most important. Even though you have the very nice algorithm, it works very well, but with the feature selection, no, I don't think you can get the good quality of the cluster. It's not only for the cluster, it's for any data analysis. And when you have the redundant information, sometimes it may increase. So like, for example, male or female, woman or man. So same data, it increase only the dimension only. So that the high dimensional data may reduce the accuracy. Or sometimes the sum of the data are correlated. Okay, so it increased even the efficient. Takes a long time to process. It's high dimensionality. So we try to minimize such a redundant information in our feature selection. So that is the first thing we need to do. Next one is similarity or dissimilarity measure. How can we measure? So idea of the clustering is we try to keep the similar or the related data into one cluster, if not another cluster. Then how can we represent? How can we check the approximate, whether similar or dissimilar? Euclidean distance, one of them is the data set. Definitely we can use the Euclidean distance because the characteristic of the coordinate data is the position, x and y position. So similar point means closer, the distance. So we can use the Euclidean distance measure. What about the clustering my student by the shape? It's very hard. So how can we measure the similarity between two students? How much is similar or not? Yes, that's doable. That is a problem of face recognition. So using the different face, we try to, that is a reason. So sometimes we can select the point of interest in the face. So we try to check the distance between the eyebrow and between the eyebrow and the size and the angle and the relative position. Then finally we characterize the face. Okay. Then take out the 47 point of interest as a feature. That is reasonable. Then using that information we can compare. Then problem is how to compare. At the time we can apply the traditional the Minkowski distance or the L1, no, L2 long, and Mahalanobis distance if that is the vector. So we can apply the many different approximate measure. Also, if we want, you can define your own approximate measure. That's usually happen for the specific data set, which is not well known. For example, nobody used the similarity measure for the face recognition. So I have my own, for example, weighted Euclidean distance, something like that. Then sometimes, even though we are using the same feature, and exactly same algorithm, but the only difference is the approximate measure. The result is totally different. Okay? So that is one thing. In other words, when you are doing the research, You don't have to worry about too much whether I copy the existing algorithm, I'm using the Chemist clustering algorithm, whether I do not propose a new algorithm, but in your data mining algorithm, why don't you consider different feature? What different? Similarity measure. Then the result is hugely different. Okay, then the clustering criteria means, so when we form this cluster, what is our goal or objective? We try to minimize the distance between 2 points, all of these 2 points, okay? That is the cluster, that is the objective function. Or if we can define this one as the Gaussian distribution, we will see the density at the model-based the clustering algorithm. So the data in this, the cluster form the Gaussian distribution, which means this Gaussian distribution can be represented by the two parameters. One is sigma, the mu, and sigma, the mean and variance, the two parameters. So we'd like to use such a Gaussian density function as our objective, our goal, our core function. So then we'd like to fit to the parameter value to this one using the, for example, likelihood function. At that time we can use the likelihood function. So why don't you remember your statistics? If you do not take the statistics, why don't you search it, Wikipedia? So that is the shortest way, but I suggest to read the statistical textbook. It's probably the freshman or sophomore level, the statistical textbook. They mention about the likelihood function and log likelihood function, and then the purpose, the objective of such a the likelihood function is to find feasibility of the parameter value, to find the parameter value using such a data. At that time, that is called the clustering criteria. In other words, it's a kind of object function. Central analysis that you are doing is what kind of function you use. Depending on how to define the centrality, it may be different. So that is the clustering criteria. Then finally, how to determine the algorithm, logic, process, that is a cluster. So it's not only for this one. Many students, many people focus on only the algorithm itself, but the clustering analysis includes many other important steps. Feature selection is one of the important ones. And also the approximate similarity or dissimilarity measure, and the object function, and algorithm itself. Also, after you run this one, we need to evaluate the clustering, quality of the clustering also. How can we judge after we got the two clusters whether this algorithm working very well or not? What is the quality of it? How can we measure? That is the validation of the result. And how can we understand the result? It's an interpretation of the result. Okay. After you got the very nice cluster, that's it. So we should be able to understand the result of the cluster. Whether this is a normal, this is abnormal, this is a fraud, this is normal transaction, something like that. Whether both of them are normal, so we try to find the outlier. So this is a very important step that you need to keep your mind. Sometimes we can focus on the specific step. So, for example, we try to focus on the approximate measure. I try to propose a new distance measure instead of the Euclidean. So then we will use the other part, we will use the existing approach. Then you can compare the result of yours with the new, the approximate measure with the current one. Then if that is better, that is your research. Okay. Okay. What is a good? What is a bad cluster? Good cluster. Anyway, based on our definition, so we try to keep the similar or the same data into one cluster. Otherwise, other clusters are good. Based on that idea, good clustering means what? High intra-class similarity means, what is the intra-class? Intra. Intra usually means same. Okay? Inter means other. So I-95 is an interstate highway because it crosses the Florida to the Maine. Okay? It's a different. So high intercluster. Intracluster because it's the same group, same cluster. And low, the intercluster similarity. So if I belongs to the different from you, you and me should be the low similarity, high distance. Okay? So this is the low similarity, it's a distinctive. So that is the same, actually the idea as from the definition. So quality of cluster depends on, as we have seen here, actually all the step affect the quality. Feature, definitely. And proxy measure and the cluster criteria, if you have the objective function, it can be different, the result. Okay? So also sometimes, anyway, our goal is, so when we have just the data, like this, we do not know what is the cluster, what is the knowledge. So that is called the hidden knowledge. In this case, it's obvious, but even we have in case we have the 4-dimensional, 5-dimensional, hyperdimensional data, it's very hard to imagine which data belongs to which cluster. So that cluster should be able to find such a hidden error. Okay. So how can we measure such a quality of the clustering? It's the same thing. We try to implement such idea: high intra-class similarity and low inter-class similarity based on the something distance function. This is not just the Euclidean distance. Euclidean distance is one of the examples. It can be weighted Euclidean, it can be the Mahalanobis distance, it can be the Minkowski distance, it can be cosine distance, it can be any other distance. So you based on that, any distance measure. And also, typically that is a metric. What is a metric? Have you ever heard about the metric space? Metric means that support inequality property. What is the inequality property? So when we have the three data, the distance AB plus AC is bigger than BC, equal or bigger, no matter where it is. Okay, that is triangular inequality property. That means we can make the order of the point, order of the data, whether this one is similar, this one is not. However, similarity like the similarity of the face. I have my own similarity measure, so he and he is similar. Then he is similar to him. Can I say he is similar to him? No. You don't know. That means it's not, my similarity measure is not metric space. Okay. However, I can say the distance between he and him, then this distance is bigger than distance through him. Okay, that is a metric space. So because most of the Euclidean distance measure and such distance measures are metric space, we can make the order. We can make the index. We can search the data based on the rank. Okay, that is a metric space. Then, if this similarity or similarity measurement is the metric space, we can determine the quality. We can make the rank of the cluster. Okay. But it's varies depending on the type of the data, like the Boolean or categorical data or ordinal ratio, the variable. It depends. Sometimes weight should be considered as the weighted Euclidean distance. So if I have the 1 to 3 element attribute for the feature vector, so A is the first one is the most important one. So I can give the 60% of the weight and 20% for second, 20% for the third, like the weighted measure. Okay?
But Professor,
Yes.
how can you specify which one is the best 60, which one is the second?
It depends. So that is the good question. So that is the part of the feature selection. Okay. So if that is the training based like a classification, we can easily find how much bias, how much related to the each attribute to the result class. Okay. Then we can give the weight. However, in clustering, it's not easy. Sometimes it is based on the empirical result, which means you learn the several times and to find the best one. Then based on the best result, it's sometimes subjective or sometimes the domain expertise. If you are dealing with the patient information or the hospital, the probably medical doctor is the best one who decide whether this is a cluster for cancer, this is the negative, this is a positive case. Then determine the result with the attribute, which attribute are related to that cluster using the correlation or the something the PCA. So that we have discussed in the last week, how much related each attribute to the result. Okay? Then we can give the different weight. Also based on your experience. Or you can test the different value. Like the equal and what to give the higher weight and something like that. What about the yours, the brain? So when you train, it's automatically adjust. So that is the actually the good indication to characterize something problem or the data. Sometimes the frequently happen. The frequency does not mean the important. Okay, it is user the frequently happen data is the something knowledge, but if something unusual rarely happen, but they may cause the big change or impact. Okay, even though that is for example, I'd like to. This is one of the good example in the social media data mining or the social media data analysis. So for the sentimental analysis, which means whether Microsoft has currently good reputation or not. So how can you decide from this Twitter and Facebook data information whether Microsoft is currently good reputation or not? How can you? If you can see bad word, so Microsoft is suck, or there's something like that, they should leave the earth, then you can see the Microsoft new product of the Microsurface, the 3 is the something wrong or the bad reputation. Okay, so you can find something bad word or something good word, perfect or nice, one of the best. So if you can see such a word. Okay. However, if something frequently happen, that is the good one. But what if the some word is not frequently happen, but it impact a lot, like the obvious word. Okay, but it's not frequently happen, but very good the impact. For example, terrible. Okay, terrible is not frequently used, so it's not good. It's not frequently frequent our database, but the terrible means definitely is wrong. Okay, so you need to consider such a thing sometimes. So it's not easy to give the different weight. Okay, so such a sentimental analysis can be used for what? To make the money. stock market trading. So economy is not science actually, it's kind of the emotion, feeling. Okay? Who knows, who can decide whether the economy is going well or going bad? If somebody, most of the people around me buy the house, I'd like to buy the house. Just follow the feeling or the overall. So that's the reason that somebody, the very famous the economist said there's no, there might be invisible hand. It's an invisible hand to control the economy. Actually, nobody controls the economy. It's kind of the feeling, okay? Whether it's going well or going bad. If that is true, so when we buy the stock for the market, without considering the very complicated number, just take a look at the Facebook or the Twitter or hashtag data, whether the reputation is good. If, for example, Microsoft released the new version of the Surface, then without checking the number of the Surface itself, you can just check the comment, overall trend of the comment, whether it's going where it's a good comment or the bad comment, then you can see probably if you can see a lot of bad comment or there's something wrong, so there the stock will be the lose the stock price, something like that. So that's another way to analyze the financial data nowadays. But still not easy to find such a good similarity or the dissimilarity. Okay, it's a very subjective. So we can consider different types of the clustering analysis. Let's skip this part. There are some requirements of the clustering analysis that we are going to discuss. One is the scalability. Scalability means I test my new clustering algorithm with 100 data set. Works perfect, but the only problem is it takes 2 days to complete the clustering analysis only for 100 data set. What if we have the 10,000 data set? It will be forever. So it's not scalable, so we need to consider such a scalability. Even nowadays, we are dealing with the big data. So big data usually the petabyte size data, exabyte size data. So how can we cluster? Also real-time data, like we have the incoming. For example, the many of the company, they try to analyze the hashtag information. So every moment, we have the 100,000 of the hats, the Facebook message or the tweet. So how can you analyze such a real-time data? So scalability is one of that. Also different types. Nowadays it's not only just the numerical data or the numerical data. It can be binary data, categorical data, ordinal data, linked data, mix of them. Also nowadays graphic data and XML data, unstructured data, video data and image data. So many unstructured data also can be considered. And what if the constraint-based the clustering, which means we try to give the certain limitation or assumption. Okay, that may be doable. So that may increase the dramatically, increase the performance as well as the accuracy, such a constraint-based. However, still discovering the arbitrary shape means, so for example, this is just one, the extreme. This is just one example. When we determine the cluster like this one, in terms of the two-dimensional data, x and y coordinate, finding cluster like this, not very difficult. However, if the data is formed not easy. Okay? And even arbitrary data shape is more difficult. Okay? you consider something the approximate measure for the cluster is usually formed, the ideal case is like the circle shape or the oval shape. Okay? But arbitrary shape is not easy. There are solutions, several solutions to address the problem of this one. Also, sometimes you need to consider such an arbitrary shape. How can we deal with the noise data? So we have the linear data like this one. This. Can we say this is one cluster and another?
No.
So that is the noise data. So we need to discard sometime. But sometimes many of the clustering algorithms consider this is one of them. Should consider. We will see the Chemist algorithm first one. The Chemist depends on the reliance. Not the invariant for the such outlier data can be affected. And also incremental data is nowadays very important. Incremental data means that the static data is not changing, so we can analyze, then cluster. What if there's new data coming? We need to run the algorithm again. Can we adjust the algorithm? That is the incremental clustering. So incremental clustering nowadays is very important for the streaming data. Streaming doesn't have to be the analog continuous data. It can be discrete data, but the continuous income, like the Facebook hashtag data, or one of my students doing the event detection for the tweet information at the time. Even though you collect the data every hour it can be considered as incremental. So your algorithm is working very well at certain time. What if there's a new data? So can we process whether there is a new event or not? That is kind of the incremental clustering algorithm. Okay. And what about the order? Order of the data. Like the frequency analysis, consider the order of the data. Not really. But anyway, so if ABC is different from the CDA, yes, that is different to some of the algorithms. Okay, so we need to check the order of the input data and definitely high dimensionality. So we need to reduce the dimensionality with the dimensionality reduction technique. Okay. So these are the major approaches of the clustering analysis. Partition based the typical method is Chemist, K-memory, and we will see such an example today first. Then there is a hierarchical approach. Hierarchical approach means just like the he and him is similar, make the one group, and he and him is the similar, so make the one group, and the average of them are similar, then make the another group, and from bottom to top, so we can make the kind of the dendrogram is a hierarchical approach. And vice versa, from the top. So I consider this student as a one group and find the two group bisect. Okay, like the man and woman, male and female. Then for the man and long hair, the short hair, and the jacket without jacket, something like that. I can apply the different criteria or the same criteria and the bisect. That is a hierarchical approach. So and density based. So for example, I can see a lot of students sit over here. So I consider this one is high density, which means they are close, which means they are similar in terms of position. So I can make the group. Another high density is here, so I can say this is another. So that is a density based. How much data are based on the connectivity? How much they are closely connected? That can be used for social user mining also. If we analyze social media data, so mostly the idea of the social network, social media data is the connectivity, right? It can be connected by the friendship, it can be connected by the follower, it can be connected by the participation to the group, or something like, something common, something friendship. So that can be represented by the density, how much they are close to each other. Then if they are close, then if they form a group, that is one community. Even though I do not, so that is one of the good examples. The Facebook, how many Facebook friend do you have in your Facebook? I have the less than 100.
I have like 150.
So let's say I have 100. So some of them are family, some of them the high school friend and the college friend, the UB friend. But every time first time I classify them, nowadays no, I don't care. So, but if we can use something such a density or the connectivity, how can we define the connectivity in the Facebook group? Like we can use the common word that we are. So probably when I send a message or receive a message or communicate with a high school friend, their terminology or their word are different from ones used in the college friend or the UB classroom, right? So UB classroom, for if I form a data mining class, the friend group, probably we will use the homework or the mining or the lab or the project, something like that. This word. So using this common word, we can define such a connectivity. Then we can apply the density-based approach to automatically identify the friend group. Great, based, not very popular nowadays. I'm going to skip. And model-based, so we try to use the model, specifically statistical model, okay, like the Gaussian mixture model, which is the most popular one, or you can use the other, the statistical model. But 99% the model-based approach, they use the Gaussian or Gaussian mixture model they are using. Then we try to find such a parental value of each Gaussian. We will see details about such a model-based clustering. And frequent pattern also can be used for the clustering algorithm. If we can find the frequently happen, the pattern that they can form the cluster. Okay? And linked-based clustering can be used for the social media data for connectivity, okay? So or the group graph. So first, partitioning based one. Idea is we try to partition So we have the A point here. So A data set. So we try to partition into two partition. We try to make the two groups. So this is the assumption. So I try to make the two number of the two cluster, two group, two partition. Okay, then the first initially I can set the I try to follow the step of the cluster analysis. The feature is so we try to use the x and y coordinate. Okay, and for the similarity measure, actually this similarity measure, I try to use the Euclidean distance. That is the best way to represent the closeness or the distance between 2 points, 2 data. And our goal, okay, objective, core function, our goal of each cluster is this one, okay? This is the sum of the distance. Distance from what? The centroid. Centroid means if we have the something group of the data. Let's say this is x and y coordinate. So this is that is the easiest way to understand the centroid. However, it doesn't have to be x and y coordinate. It can be any feature vector as long as we can average it. So what is the middle value of the x? You can x1, x2, x3, x4 and divide by 4. Let's say that is here. So here, and y is the same thing. y1, y2, y3, y4 and divided by 4. So this is the middle point. This is called centroid. This is called the representative of the means cluster. So our goal, our objective of the partition-based approach is we try to compute all the distance between centroid and point. Centroid and point, centroid and this is all every point. And minimize the sum of this distance. So that is here. So that is the distance between the centroid and each point. Each point belongs to the cluster, and K is the, if we have this cluster, let's say that we are going to do the two partition. So we have two clusters, which means K is equal to 2. And sum of this point should be the minimum value. Okay, that's our goal. 1. What is the goal of the cluster? The similar in one cluster, they close to each other. If this one belongs to here, and distance is very large. Okay, that is our goal. That is called objective function. So this is the objective function of the partition. Any partitioning based approach use like this, the objective function. However, I do not say this is the Euclidean distance. In this example, we can use the Euclidean distance. As long as they are that which is the metric, then it's okay. So it can be any other, dissimilarity or similarity measure. Okay. So partitioning based approach. Partitioning, the algorithm is we try to minimize the sum of the distance between the centroid and point is the we try to minimize that one. That is our objective. So there are many the partitioning based algorithm. Most popular one is the K-means algorithm. Okay? What does that mean? Means average. So we try to use the average to determine the centroid. What about the medoid? Medoid means K-medoid use in this the centroid. This one is not real value, real data. Okay, it's the ideal case. Okay, so instead of the ideal case, we try to find the closest real value. So that is a K-medoid. That is the only difference. But there are many variants: K harmonic, K hybrid, K something. But all of them are same idea. Okay, they are using the partition based. Therefore, objective function is like this. But they are using different distance metric. Okay, sometimes different, little bit different variants of the objective function. So in your second project, why don't you read the paper first that mention about the variation of the K-means algorithm. Then with your own code, you will implement such a K-means algorithm. So let's take a look at the K-means algorithm first. So in this case, we are going to find the two means. Two means is K represent number of partition, number of cluster, number of group. So we try to find the two groups first. First, we need to select initial centroid. Because without centroid, we cannot compute the distance. So arbitrarily, we select one point here, one point here. Okay. So then compute the distance between all the point. Then find the nearest one. So for example, the centroid, there is a missing part. The arbitrary partition. There are two ways. So we can arbitrarily partition like this way, okay? Then find the centroid of this group. But more general implementation, actually, the randomly select the 2 points from here. So I select the 1 point here, I select randomly one point here and decide the membership, whether this point belongs to here or here. Okay? How can we decide? Closer one. Okay? Then, for example, we have this node, this data belongs to this one, this node belongs to this one. Anyway, we can have the new centroid among these, so we can average mean value. That is the reason it's called the k-means. So mean value, x and y, so we have the new centroid. Then same thing. Compute the membership, whether this node actually close to this one, not this one, right? So the data belongs to this centroid. And what about this? This one is close to here. So the other, what about this? This one actually belongs to here, first time, but this time, this one close to this centroid. So membership is changed. So this is a new membership of the cluster. This is another cluster. Using that, we can compute the mean value, centroid again. You can see the centroid is moved to here, right? And this one is moved to here. So it's a new centroid. You can do the same thing, so check the membership and compute the centroid. Until when? Not change. It's in other words, converge to the specific point. So usually it's converging, but we don't know how many iterations we need. Okay? So sometimes you can stop. Little bit slight. When you have the very large data, it's a slightly change it, but at that time you can stop. Or sometimes it's a fluctuate, slightly. Okay? The membership is changing every time. So you can stop at certain points. It doesn't have to be until no change, within something delta value. Then we can have the finally one cluster and another cluster. That is a k-means algorithm. Once again, the first, it can be arbitrarily partitioned, or it can be randomly select the initial point. Then we decide there are two steps always. Decide the membership, then compute the new centroid with the mean value. That is the reason it's a mean. Okay? Then the iterative, you can repeat until no change it, then that is a finite cluster. Benefit, advantage,
Exhaustive search.
benefit, advantage.
Disadvantage.
I mean the advantage first.
Okay.
Simple. Everybody can understand nowadays. And reasonably work. So this one is used a lot of application. Okay? And always provide such a convergence and a cluster. Yes.
If we have data updated frequently, so
If we update the data,
yes.
then maybe change it. Okay? So it's not incremental. Okay? If we have the new data, it's changing. So you need to run. Okay? That's the disadvantage. The advantage is simple and reasonably provide the accuracy, reasonable accuracy, quality of the cluster. Then problem.
Exhaustive search. You have to compare each centroid.
Yes, it's the computational. So I'm not sure it's there's yeah. Actually, it's fast comparing to others. Okay, even though it's you can just scan one time, then it will be. It's
Professor,
K.
disadvantage is you need to, so sometimes you don't know how to specify how many clusters you have.
Yes, that's one of the big problems. The K. We don't know whether this is a K equal 2 or 3 or 4 or 5. That's a huge problem. I think that before that, it's comparing to other data mining technique is efficient. Because it requires exhaustive but just one time. Number of n, number of k, and number of t. And it's the number of object, cluster, and the iteration. Okay? So you can reduce the number of iteration by using the delta value, threshold value. Okay? So comparing to the other. like the graph search. It's usually the square, the n square. It's a huge difference. Okay. Problem, the k. We don't know how many clusters. That is our goal actually. So if we set up the 3, it's huge different from here. And 4, totally different. So that is the big problem. Another one, we already mentioned several times. Here, starting. So you can see the arbitrary partition. I want to do this one, or I want to this one, I want to this one, depending on the initial partition, initial cluster, output will be changing. Okay. So two main problems actually. So one is the number k. So we don't know what is the optimal, the number of the k cluster before we start. Even after the initial result, we are not sure. Okay, whether this is correct. The human being should be intervened, like the feedback. Okay, and another big problem is initial cluster. Even though we know the how many, but depending on the initial value, output may be different. So there are two problems, but still it's a popularly used because it's a reasonable, it's a simple and efficient